Hello my friends, welcome to Untitled channel. This is Uncle Misha with you, and today we're gonna be talking about this little development board. So this is HUZZAH ESP32 from Adafruit. I got it quite a long time ago, but it was sitting in my bag for a while because I didn't have time to actually play with it. And today is the day that we're gonna take a look what the heck we got. So what is this HUZZAH32? Well, this is ESP32 based breakout board. As you see, it has tons of pins right here, and you can have all sorts of stuff you want. Obviously, it's just not just ESP32 Expressive 32 module. There is also buttons. It has also a voltage regulator and LED. I think it's a one LED right here. So let's talk about what does it have. So ESP32 HUZZAH32 let's say based board consists of Expressive developed microprocessor, which is dual core. So this is 240 MHz dual core 10 silica LX6 microprocessor. It's pretty fast. So it has integrated this module. It has integrated 520 kilobyte of SRAM. It has integrated a HT40 Wi-Fi receiver, baseband stack, and LWYIP. It has integrated dual mode Bluetooth, which works with classic, and Bluetooth low energy. It has 4 MB flash included in WROM32 module. It has onboard PCB antenna, which is right here, and it has ultra low analog amplifier for this purposes. It has also Hall sensor somewhere underneath. This is something I have to figure out how to use this Hall sensor. Somewhere underneath here should be under this CAN Hall sensor. It has 10 capacitive touch interfaces, so some of those pins can be configured to be a touch capable. It has 32 kHz crystal oscillator, which it's not it's probably under this CAN as well. So I thought for a second that it's somewhere here, but it's not. It should be under this CAN, and has 3 UARTs and configurable, and one of them is actually right here. So for your convenience, it just that has pin outs available right here. It has 3 SPIs. It has 2 I2C. It has 12 ADC input channels. It has 2 I2S audio. So this is pretty cool because this thing has I2S audio bus. So this is amazing because you can stream some audio data over I2S to something like Cirrus Logic digital to analog converter, for example. It nicely works with I2S bus. It has 2 DACs. It has obviously PWM timer, timer input, output available on every GPIO pin. So essentially every GPIO can be configured as output. It works with OpenOCD debug interface. It has 50 MHz SDIO, and it has SD card interface capable or support. So if you take a look a little bit closer on this board, so we can see many additional elements. So right here there is a voltage regulator. It has 2 buttons right here, then it has 1 LED. There's a few miscellaneous elements around it. If you turn around, there is a breakout for external power. So over here you can connect your battery or just a connector which you can supply your power. So it is 3.56 volt DC capable, and obviously battery capable as well. So we've discussed all the features of this device, of this breakout board. So how do you connect it? As you see, it doesn't have any USB, so this not gonna go together. And I mentioned before that this device has a require and has dedicated RX and TX pins for bootloader to talk out from this board to the outside world. So after we talk about all those features, let's talk about how to connect this device. As you see, it doesn't have USB port, so this not gonna work together. But this device has dedicated RX and TX pin, serial pins right here, and also V in and ground. So those four you will be using to power it up and connect this device. What do you need? You need something like these. So you can use any one you choose. This one, for example, from PL, this one from a company called HDM. I actually like this one from FTDI. So all you need is USB serial converter. So you have different several kind of them. I choose this one because it has switchable logic level, so you can switch from this one. I think this one is CH340G, CH340G. So it has switchable logic levels, and it also has 5 and 3.3 volts supplied here. So you can do several things. You can supply this V in with 5 volt, or you can connect directly to this 3 volt rail, which is after the internal voltage regulator to power up the whole thing, or the ESP32 chip. So let's exercise a connectivity using this device. But before we do that, we have to solder headers right here. So we need at least 4 headers for ground, V+, TX, and RX. So I would choose to use 5 volt to connect to V in. But before we do that, let's talk about power. So this little voltage regulator right here, it's tiny one here. Let me take some kind of pokey bit here, take a screwdriver, and right here, this voltage regulator, right? And here are some specs. This voltage regulator is AP2112 3.3 volt. This is from the Yoris Incorporated. Very interesting that these specs are provided by 4.3 volt VN, input voltage, 3.3 volt output voltage. In this all specification, there is no data for minimum V in. There is a data for maximum V in, which is 6.6 volt, absolute maximum, but regular maximum is 6. So right here on the back we have V plus 3.5 to 6 volt DC, V battery 3.5 to 6 volt DC. 6 volt I understand, 3.5 I do not understand. Why? Because this at 600 milliamp hour, this chip can do milliamps, sorry, forget it, milliamp hour. You have absolute maximum 400 millivolt drop. So if you supply it with 4.3 minus 400 millivolt, you're gonna have 3.9. This is something to think about. So if you supply, for example, this 3.5 volts minus 400 milliamp at 600 milliamp load, how it's gonna work? It's lower than 3.3 volts. So this is something very important for you to understand. So now let's talk about how much this chip consumes. So documentation says a maximum load, total load 500 milliamp, but we know that this is 600 actually can do 600. Half of it is taken by this chip, so 250 milliamp consumed right there. So we're gonna have about 125 millivolt to 200 millivolt drop. This is something very important. So so something to consider. So if your input voltage with this particular load will drop too low, this voltage regulator will stop regulating. So I'm not sure how you're supposed to actually use external battery right here. Okay, no problem using some USB power or something like that, or 3.3 volt from some kind of external voltage regulator. If you are using battery, specifically lithium polymer battery, the voltage there can drop at 2-3 volts. So this voltage regulator will stop regulating. It probably stop regulating even sooner than that. This says 3.5 volt. My calculation says it's gonna be like 3.7 volt, but yeah, sure, something to check, something I'm not sure about. So maybe during playing with this device later I'll figure out what is actually minimum voltage you can apply it right here. I can do an experiment with my power supply, but at the moment, without much of a knowledge poking around and dropping voltages, I probably won't do that, not to, you know, damage the guy. So yeah, not sure what this chip gonna do if it stop regulating. Either completely cuts off or start providing the output input voltage as output. I have no idea. I do want to experiment with that. So this is something to still figure out, but there is some kind of, let's say, red flag for me. So there is some kind of convoluted information provided for a voltage regulation for this, for powering up the board. So yeah. Anyways, so let's just quickly solder the headers and connect it to my CH340 serial USB to serial chip and see how it's gonna work. Now, when we soldered our header right here on the board load, so let's connect our USB to serial converter dongle to the board. So first of all, we have to figure out where is the ground and voltage. So we're gonna supply this guy with 5 volt, so it's gonna go through its built-in voltage regulator. So this is our ground, 5 volt from here. So we connect to V+. Our ground is green right here. This is green, so connect it here to green. So now is RX TX, so yellow is RX, so yellow RX gonna be connected to TX right here, orange TX gonna be connected to RX, so it has to cross, right? So this is how it's gonna be connected, RX TX, RX TX. So RX here should be connected to TX here, and RX here should be connected to TX here. So now we are ready to connect it to our computer. So when you connect to your computer and try to upload it, well, make sure that you have everything installed in your Arduino IDE. So you have to switch board every time you upload any kind of sketch or firmware to the board into bootloading mode. So for this, you have to hold this button, GPIO, then press reset, then release reset and release the GPIO button, GPIO 0 button. So this will trigger the board that you can upload any sketch into it via USB serial dongle. So when your firmware uploading is complete, you just hit reset and your sketch will kick in, it will start working. So let's do it right there on the computer to see how it works. So before we start doing anything, we have to pick our board. So we have to go ESP32 Arduino and then pick Adafruit ESP32 Feather. And obviously don't forget to change your COM port. Okay, so in my case it's COM58. Next, you have to open your example. And today we're gonna pick Blink, the simple example you can get. This is very generic, gonna work on any platform. Now we can compile and build. It's gonna take some time. In my case, I do this debug information. I show this debug information for users to see. In my case, I show this extended debug information just to see if something go haywire. I would be able to see some logs. So it usually takes a little bit more time because of the tons of text, but it's worth it. So all right, we found our port. Now it's writing and to be good to go. And now in order to get your sketch running, just hit the reset, or hit the reset button on engage the reset pin. Now I try to get some board info, but it's not really working. So now we uploaded our sketch. Let's power it up here right on a. Now we are not connected to the computer, but our very simple sketch is blinking. So that was very, very simple. Alright guys, I think that was a very, very simple way of actually starting playing with HUZZAH32 breakout board. This is very simple and inexpensive board, which is actually quite powerful. It can power your any sort of IoT and remote sensing project, you name it. I think, let me disconnect it from here. I think this little board, I have few ideas what I can do with it, so stay tuned. You can probably see some very interesting project coming down the pipe. But for now, I just give you an introduction to how this board works. At the same time, I learned how it works myself, because it was sitting in this little baggie right here for really long time. I just decided to finally pull it out and start playing with it. So guys, I hope this video was useful. Have any comments, please fire it up, like and subscribe, and stay tuned for next video. Ciao, stay safe.